Formulae. 1. How to write formulae of ionic compounds from ionic charges and oxidation numbers, shown by a Roman numeral. Figuring out formulae of ionic compounds. The formula of an ionic compound is calculated by the charges present on each of the ions that the ionic compound contains. The number of positive charges of the cations, positive ions, is balanced by the number of negative charges of the anions, negatively charged, so that the total charge on the compound is 0. Examples. A. What would be the formula of magnesium chloride which contains the ions Mg2 and Cl? Answer. To balance out both the ions present in the ionic compound, we require 2 Cl ions for every Mg2 ion. 2 times 1 plus 1 times 2 plus equals 0. Hence, the formula is MgCl2. B. What would be the formula of aluminium oxide which contains the ions Al3 and O2? Answer. To balance out both the ions present in the ionic compound, we require 3 O2 ions for every 2 Al3 ions. 3 times 2 minus plus 2 times 3 plus equals 0. So, the formula is Al2O3. Oxidation numbers shown by a Roman numeral. Roman numbers are used in brackets to name compounds. We use these systematic names to distinguish different compounds made of the same elements. For example, there are 2 types of iron chloride. We show the difference by naming them iron 2 chloride and iron 3 chloride. The numbers in brackets are the oxidation numbers of the iron. In iron 2 chloride, the oxidation number of the iron is +2. The compound contains Fe2+ ions. The formula is FeCl2. In iron 3 chloride, the oxidation number of the iron is +3. The compound contains Fe3+ ions. The formula is FeCl3. We can also use oxidation numbers to distinguish between nonmetal atoms in molecules and ions. A. Prediction associated with the ionic charge from the position of an element present in the periodic table. The diagram below illustrates the charges on some simple ions relative to the position of the elements present in the periodic table. The form of the periodic table shown below has 18 groups because the transition elements are numbered as groups 3 to 12. Hence, aluminium is present in group 13 and chlorine is present in group 17. For metal ions in groups 1 and 2 of the periodic table, the value of the positive charge is the same as the group number. For a metal ion in group 13 of the periodic table, the value of the positive charge is 3+. For a simple non-metal ion in groups 15 to 17 of the periodic table, the value of the negative charge is. The group number 18, group number 15, 16, 17 equals, hence we get -1, -2 or -3. The charge present on the ions of transition elements are known to vary. For an illustration, iron forms ions of 2 types, Fe2+ and Fe3+. B. Recall of the names and formulae for the following ions: NO3, CO32, SO42, OH, NH4+, Zn2+, Ag+, HCO3, PO43. 2. A. Write and construct equations, which should be balanced, including ionic equations, which should not include spectator ions. Write and construct equations. When chemicals react together. Naturally, atoms cannot be either created or destroyed. So there must be an equal number of each type of atom on the reactant side of the chemical equation as there are on the other, product, side. A symbol equation is known as a shorthand way of describing a chemical reaction. It shows the number and type of the atoms in the reactants and the number and type of atoms in the products. Ionic equation. When ionic compounds dissolve in water, the ions are separated from each other. Ionic compounds include salts such as sodium bromide, magnesium sulfate, and ammonium nitrate. Acids and alkalis also contain ions. For example, H+, Aq, and Cl, Aq, ions are present in hydrochloric acid, and Na+, Aq, and OH, Aq, ions are present in sodium hydroxide. Several chemical reactions present in aqueous solution involve ionic compounds. Only a few of the ions present in the solution take part in these reactions. The ions that are involved in no part in the reaction are called spectator ions. An ionic equation is known to be simpler than a full chemical equation. It shows only the ions or other particles that are reacting. Spectator ions are omitted. When we compare the full equation for the reaction of zinc with aqueous copper, 2-sulfate with the ionic equation, this approach can be observed. In the ionic equation, you will notice that sulfate ions are not present. Sulfate ions are only the spectator ions as they have not changed during the reaction. Charges of both the ions and the atoms are balanced as observed in the equation mentioned above. B. Use appropriate state symbols in equations. We use the following state symbols. S. Solid. L. Liquid. G. Gas. AQ. Aqueous, a solution in water. State symbols are generally written after the formula of each reactant and product, in brackets. 3. Define and use the terms empirical and molecular formula. Empirical formula, the formula that amounts to the simplest ratio of the different atoms present in a molecule. Molecular formula, the formula that amounts to the actual numbers of each type of atom present in a molecule. The formula for an ionic compound is always known to be its empirical formula. The empirical formula and molecular formula for simple inorganic molecules are often known to be the same. Organic molecules often have different empirical and molecular formulae. For, understand and use the terms anhydrous, hydrated, and water of crystallization. Anhydrous, a substance is anhydrous if it is known to contain no water. Hydrated, a hydrate is a substance that contains water or its constituent elements. A hydrated substance, hence, would contain water. Water of crystallization is known as the state where water molecules are present inside crystals. Water often results in the formation of crystals from aqueous solutions. 5. Calculate empirical and molecular formulae using given data. The empirical formula can be deduced by determining the mass of each element present in a sample of the compound available. An empirical formula can also be calculated from the data given in the form of the percentage composition by mass of the elements in a compound. Molecular formula. Molecular formula is often used to write balanced equations and to calculate molar masses. The molecular formula is always known to be a multiple of the empirical formula available. For example, the molecular formula of ethane, C2H6, is 2 times the empirical formula, CH3. To figure out the molecular formula, we must have the following information: the relative formula mass of the compound, the empirical formula,